Aristarchus of Samos was an ancient Greek astronomer and mathematician who lived around 310 to 230 BCE. He was born on the Greek island of Samos, which was also the birthplace of another famous ancient thinker, Pythagoras. Not much is known about his life, but his astronomical work left a lasting legacy. Howdy. I'm just some random nude dude sitting in my closet talking to myself. It's also where I celebrate the power of free thinking and encourage bold ideas. As a society, we're often afraid to challenge the norms and think outside the box. But here, I embrace the unconventional. So sit back, relax, and join me on this journey of exploration, where we embrace our inner nude dude and push boundaries to discover new perspectives. Aristarchus of Samos, an ancient Greek mathematician and astronomer, is a figure whose revolutionary ideas and pioneering spirit have left an enduring legacy in the annals of science. Born on the island of Samos in the 3rd century BCE, Aristarchus lived in an era when the prevailing view of the universe held Earth as a stationary center of all celestial motion. However, his insatiable curiosity, innovative observations, and groundbreaking proposals challenged this geocentric doctrine and laid the groundwork for a profound shift in our understanding of the cosmos. This discussion embarks on a journey through the life, work, and enduring influence of Aristarchus, exploring the key facets of his contributions to science and astronomy. From his audacious heliocentric model to his estimates of the sizes and distances of celestial bodies, Aristarchus defied conventional wisdom and, in doing so, provided inspiration for future generations of thinkers. As we delve into the life and background of Aristarchus, we'll consider the intellectual environment of his time, his contemporary influences, and his commitment to astronomical observations. We'll also investigate his challenges and opposition, as his groundbreaking ideas faced resistance from a geocentric worldview deeply rooted in Greek philosophy. Our exploration of the heliocentric model will take us through the essence of his revolutionary proposal, the use of lunar eclipses to support his claims, and the broader context of heliocentrism versus geocentrism in the ancient world. Aristarchus's ideas, though not widely accepted in his era, sowed the seeds for a paradigm shift that would take root centuries later. In the section on size and distance calculations, we'll delve into Aristarchus's innovative methods for estimating the size of the Sun and the Earth-Moon distance, acknowledging both their limitations and their profound impact on the development of astronomical measurement techniques. Finally, we'll uncover the lasting legacy and influence of Aristarchus, tracing how his daring ideas inspired thinkers like Copernicus, Kepler, and Galileo during the Renaissance, culminating in the fundamental transformation of our understanding of the universe. His work contributed to the shift from a geocentric to a heliocentric worldview, becoming a cornerstone of modern astronomy and space exploration. Through this comprehensive exploration, we'll unravel the remarkable journey of Aristarchus of Samos, a visionary thinker who dared to challenge the status quo, and in doing so, left an indelible mark on the history of science and our perception of the cosmos. Aristarchus of Samos, also known as Aristarchus the Samnian, was an ancient Greek mathematician and astronomer who lived in the 3rd century BCE. He was born on the Greek island of Samos, which was known for its intellectual and philosophical traditions. While there is limited information available about his personal life, we can speculate about the context in which he lived and his contributions to the scientific community. Aristarchus's birthplace, Samos, was a hub of intellectual activity during his time. It had a rich history of producing notable thinkers, such as the famous philosopher Pythagoras. This environment likely played a role in nurturing Aristarchus's intellectual curiosity and interest in scientific matters. During the Hellenistic period, the ancient world was experiencing a flourishing of knowledge and the exchange of ideas. Great thinkers like Euclid and Archimedes were active during this era, and their works in mathematics and science had a profound impact on future generations. Aristarchus likely drew inspiration from these intellectual currents. Aristarchus was an avid observer of the night sky. He used basic instruments like an astrolabe and observational techniques to study the movements of celestial bodies. His dedication to making accurate astronomical observations and measurements set the stage for his groundbreaking theories. The city of Alexandria, with its famous library and renowned scholars, was a central hub for scientific and mathematical research during Aristarchus's time. He might have had connections or interactions with scholars there, which could have influenced his work. Collaborative efforts and the exchange of ideas were common in the intellectual circles of that period. Aristarchus faced significant challenges in presenting his heliocentric model to the world. The prevailing belief in a geocentric universe, with Earth at the center, was deeply ingrained in ancient Greek cosmology, largely due to the influence of Aristotle and Ptolemy. Aristarchus's heliocentric model challenged this established order. His work was met with skepticism and resistance from many of his contemporaries and later generations. It wasn't until centuries later, during the Renaissance, that the heliocentric model gained widespread acceptance. Aristarchus of Samos was a product of his time and the intellectual environment in which he lived. He made groundbreaking contributions to astronomy and mathematics, challenging the status quo with his heliocentric model, even though it faced opposition and was not fully recognized in his era. His dedication to observation and innovative thinking helped pave the way for the scientific revolutions that followed in the centuries to come. Aristarchus was most renowned for his heliocentric model of the solar system. In this model, he suggested that the Earth and other planets orbit the Sun, with the Earth itself rotating on its axis. This was a revolutionary idea, as the prevailing belief at the time was the geocentric model, which placed Earth at the center of the universe. Aristarchus's heliocentric model was a significant departure from conventional wisdom and represented a pioneering step towards our modern understanding of the solar system. However, it faced resistance and wasn't widely accepted during his lifetime. Aristarchus is primarily celebrated for his revolutionary heliocentric model of the solar system. This concept, which proposed that the Sun was the center of the solar system with the Earth and other planets orbiting around it, was a groundbreaking departure from the widely accepted geocentric model. At the time of Aristarchus, the geocentric model, championed by Aristotle and later refined by Claudius Ptolemy, dominated the prevailing views of the universe. According to this model, Earth was considered a stationary center of the cosmos, with celestial bodies, including the Sun and planets, revolving around it in complex orbits. Aristarchus challenged this geocentric view with his heliocentric theory. He proposed that it was the Sun, not the Earth, that lay at the center of the solar system, and that the Earth, like the other planets, orbited around it. This was a radical shift in perspective. Aristarchus used lunar eclipses as a crucial part of his arguments for the heliocentric model. During a lunar eclipse, the Earth passes between the Sun and the Moon, casting a shadow on the lunar surface. Aristarchus carefully studied lunar eclipses and noted that the Earth's shadow on the Moon was round. He argued that if the Earth's shadow on the Moon was round, it indicated that the Earth was a sphere, and it followed that the most natural explanation was that the Earth and Moon both orbited a central body, the Sun. Aristarchus also attempted to estimate the relative distances between the Earth, Moon, and the Sun. While his calculations weren't as accurate as other observations, his approach laid the groundwork for future astronomers who would refine these measurements. Aristarchus's heliocentric model, although a remarkable and innovative idea, did not gain widespread acceptance in his time. The prevailing scientific and philosophical beliefs were deeply entrenched in geocentrism, and his radical proposition faced opposition and skepticism. Despite the limited recognition during his lifetime, Aristarchus's work had lasting influence on the development of astronomy. His heliocentric ideas would be revisited and refined by later scholars, most notably by Copernicus in the 16th century, who is credited with reintroducing the heliocentric model to the world and ultimately leading to its acceptance. Aristarchus's heliocentric model was a pioneering step in understanding the structure of the solar system. It challenged the prevailing geocentric view of the cosmos and, although not widely accepted during its time, laid the foundation for a major shift in our understanding of the universe in centuries to come. Aristarchus made remarkable estimates of the sizes and distances of celestial bodies. He used a method based on lunar eclipses to calculate the relative sizes of the Earth, Moon, and the Sun. His calculations were impressively accurate, given the limited observational tools available in ancient Greece. His estimate of the Sun's size, in particular, was quite close to reality. He concluded that the Sun was much larger than the Earth, which was a groundbreaking insight. However, his estimates of astronomical distances were less precise, but his approach was a critical step in the development of modern astronomy. Aristarchus made significant strides in estimating the sizes and distances of celestial bodies, particularly the Earth, the Moon, and the Sun. His innovative approach to these calculations marked a crucial advancement in ancient astronomy. Aristarchus recognized that during a total lunar eclipse, the Earth cast a shadow on the Moon. He noted that the curvature of the shadow was always rounded, which suggested that the Earth was a sphere. Building upon this, he realized that the relative sizes of the Earth, the Moon, and the Sun could be inferred. Aristarchus deduced that if the Earth's shadow on the Moon was round, then the Earth must be larger than the Moon. Further, when the Earth was directly between the Moon and the Sun during a lunar eclipse, the Moon's diameter was fully covered. He measured the angle of the lunar eclipse and estimated the angular diameter of the Moon. By knowing the angular diameter of the Moon and the Earth's diameter, Aristarchus made an approximation of the relative size of the Moon compared to the Earth. From this, he inferred that the Sun, being much further away, must be significantly larger than the Earth. While his calculations weren't extremely precise, they were a pioneering attempt at estimating the size of the Sun. Aristarchus also worked on determining the Earth-Moon distance. He observed the angle of the Earth, the Moon, and the Sun during a half-moon phase, and used trigonometric principles to estimate the distance to the Moon. His method involved imagining a right-angled triangle with the Earth-Moon line as the hypotenuse. By measuring the angle between the Sun and the Moon, he could calculate the length of one of the triangle's legs. He could then estimate the length of the other leg, representing the Earth-Sun distance. Aristarchus's calculations were pioneering efforts, given the tools and knowledge available in ancient Greece. While his estimates of the size of the Sun and the distance to the Moon were not highly accurate by modern standards, they were a significant step forward in understanding the scale of celestial bodies. His work paved the way for future astronomers and mathematicians to refine these calculations. It was a precursor to more accurate measurements and eventually the development of methods such as parallax to determine astronomical distances. Aristarchus's size and distance calculations were early attempts to understand the scale of celestial bodies. His innovative methods, even though less accurate than modern techniques, represented a crucial foundation for the future development of astronomy and our knowledge of the vast distances and sizes within our universe. Despite not gaining immediate recognition, Aristarchus's work laid the foundation for future astronomers and thinkers. His heliocentric model inspired later scholars, including Nicholas Copernicus, who is often credited with reviving and popularizing the heliocentric theory during the Renaissance. Aristarchus, despite not gaining immediate recognition or widespread acceptance during his time, left a profound legacy that reverberated through the history of astronomy and science. His ideas and pioneering work had a lasting influence on subsequent generations of thinkers and astronomers. Aristarchus's heliocentric model was a radical departure from the geocentric view of the universe, and it challenged the deeply ingrained beliefs of his era. While his theory did not gain acceptance, it inspired later astronomers to revisit and refine the idea. One of the most significant impacts of Aristarchus's work was felt during the Renaissance period. Nicholas Copernicus, a Renaissance astronomer, drew inspiration from Aristarchus's heliocentric model. Copernicus is often credited with reviving and popularizing the idea that the Earth and planets orbit the Sun, a concept that would become known as the Copernican heliocentric model. Aristarchus's earlier proposal provided a historical precedent and encouraged thinkers like Copernicus to challenge the geocentric worldview, eventually leading to a significant shift in our understanding of the cosmos. Johannes Kepler, a 17th century astronomer, refined the heliocentric model and formulated his famous laws of planetary motion. Galileo Galilei, a contemporary of Kepler, used a telescope to make groundbreaking observations, providing empirical evidence to support the heliocentric model. Both Kepler and Galileo expanded on the foundation laid by Aristarchus and Copernicus, solidifying the heliocentric theory's acceptance and transforming the field of astronomy. Aristarchus's work contributed to a paradigm shift in astronomy. The acceptance of the heliocentric model marked a departure from the traditional geocentric cosmology, profoundly influencing the direction of scientific inquiry. This transition from a geocentric to a heliocentric worldview fundamentally changed the way humanity perceived its place in the universe. The heliocentric model, as refined and advanced by later astronomers, including Kepler and Galileo, became a cornerstone of modern astronomy. It laid the foundation for our understanding of the structure of the solar system and the broader universe. The principles derived from this model continue to guide space exploration and celestial navigation. Aristarchus's legacy extends far beyond his lifetime. His bold proposal of a heliocentric model, although not immediately accepted, served as a catalyst for the revolution in astronomical thinking during the Renaissance. The subsequent work of thinkers like Copernicus, Kepler, and Galileo built upon Aristarchus's pioneering ideas, ultimately reshaping our understanding of the cosmos and leading to the development of modern astronomy. In retrospect, Aristarchus's contributions were remarkable given the limitations of his era. He demonstrated the power of creative thinking and mathematical reasoning in advancing our understanding of the cosmos. His legacy endures as an early advocate of the heliocentric view of the solar system, which is now a fundamental concept in astronomy and astrophysics. Aristarchus of Samos was a visionary ancient Greek thinker who dared to challenge prevailing beliefs with his heliocentric model and made pioneering strides in understanding the cosmos. While he may not have received the recognition or Nobel Prize he deserved in his time, his work paved the way for the scientific revolutions that came centuries later. Aristarchus of Samos, the audacious ancient Greek mathematician and astronomer, emerges from the annals of history as a figure whose pioneering ideas and relentless pursuit of knowledge left an indelible mark on our understanding of the universe. His groundbreaking contributions challenged a prevailing geocentric worldview of his time and set in motion a profound transformation of astronomical thought that would echo through the ages. Aristarchus's life and background, rooted in the intellectual ferment of his era, equipped him with the tools to question established beliefs. The rich intellectual environment of ancient Greece, with its history of philosophical inquiry, provided a fertile ground for his curiosity and originality. In a world where geocentrism held sway, Aristarchus dared to look beyond the conventional wisdom. His heliocentric model, a daring proposal that placed the sun at the center of the solar system, defined the deeply entrenched geocentric views of ancient Greece. Through careful observation of lunar eclipses and innovative measurements, he advanced the notion that the Earth and other planets orbited the sun. While his model faced resistance and skepticism, it sowed the seeds of a new way of thinking about the cosmos. Aristarchus's size and distance calculations, although less precise by modern standards, represented a vital first step in estimating the sizes and distances of celestial bodies. His methods laid the foundation for future astronomers to refine these calculations, ultimately leading to the development of precise astronomical measurement techniques. The enduring legacy of Aristarchus finds its most prominent expression during the Renaissance. Thinkers like Copernicus drew inspiration from his heliocentric model, using it as a launching pad for their own revolutionary ideas. Kepler and Galileo, armed with telescopes and empirical observations, provided empirical evidence needed to solidify the heliocentric model as the cornerstone of modern astronomy. In this comprehensive exploration of Aristarchus's life, work, and influence, we have witnessed the power of innovative thinking and the ability of one individual to challenge the established order and shape the course of scientific history. Aristarchus of Samos remains a testament to the enduring quest for knowledge and the courage to explore the boundaries of human understanding. Aristarchus's enduring legacy is a beacon for future generations of scientists, reminding us of the transformative potential of bold ideas and unrelenting curiosity. His visionary contributions to astronomy continued to inspire and inform our modern understanding of the universe, making him a celebrated figure in the annals of science and a symbol of the ever-evolving nature of human knowledge. Thanks for tuning in. I hope you found this video informative and thought-provoking. This is the point where others tell you, if you enjoyed it, please give it a thumbs up and consider subscribing for more content just like this. But we all know that kind of thing is for losers. Don't be a loser. And as always, I welcome your feedback and ideas for future videos in the comments section below. Until next time, keep exploring, keep learning, and keep embracing your inner nude, dude.